Hello students, let's revise chapter 2 chemistry, acids, bases and salts. So let's see the topics one by one. First of all, let's see acids. The properties of acids are written here. First one is it changes blue litmus red and it changes methyl orange red. So litmus is a natural indicator, methyl orange is a synthetic indicator. Then another property is in aqueous solution it produces H plus aqueous or ionization takes place and H plus ions are formed here, and this H plus ions are actually exist in the form of H3O plus. That means H plus reacts with one molecule of water to produce H3O plus, that is called a hydronium ion. So this H plus aqueous or hydrogen ions are responsible for acidic behavior. Then another property of acid is in aqueous solution it conducts electricity. Then some chemical properties are here. First one is with metals it produces salt and hydrogen gas. Then with carbonates and bicarbonates it produces salt, carbon dioxide and water. Then another property is it reacts with a base, a neutralization reaction takes place and salt, water are formed. Then with metal oxides it again produces salt and water, since metal oxides are basic in nature. So similar to neutralization reaction, here also we will get salt and water. So these are the chemical reactions. Let's see the chemical equations for these reactions. First one is with metals we can take hydrochloric acid as an example. So HCl plus zinc metal produces salt, zinc chloride and hydrogen gas. So hydrogen gas is evolved here. So this is very important. Then another point is with carbonates. Sodium carbonate can be taken as an example, Na2CO3. Then hydrochloric acid is taken again. Then salt, sodium chloride, NaCl, carbon dioxide and water are formed. So the gas produced here is carbon dioxide since it is a carbonate. So carbonate is taken here. Then another reaction is acid plus sodium bicarbonate. So with bicarbonate again salt, carbon dioxide and water are formed. Salt, carbon dioxide and water. Here acid plus a base, so HCl plus NaOH. So NaOH is a strong base and neutralization reaction takes place and salt, water are formed. Then another reaction is acid plus metal oxide gives salt and water. Here metal oxide is copper oxide. So copper oxide, the color of copper oxide is black. So you have to note the color also. Copper chloride is the corresponding salt formed here, which is blue-green in color, and water is the byproduct. So here a neutralization reaction takes place since copper oxide is a metal oxide which is basic in nature, and so acid plus base gives salt and water. So these are about chemical reactions. Then let's see about concentrated acid and dilute acids. So in concentrated acids minimum amount of water is present. In dilute acid maximum amount of water is present. So we can make dilute acids from concentrated acid by adding water. So addition of water should be done, like add acid to water but not water to acid. So this is an important point to be noted. Add acid to water in order to dilute an acid. So concentrated acid to dilute acid we can make it by adding water, but add acid to water, not water to acid. Then acids can be classified into two, that is strong acids and weak acids. So in strong acids we will see complete ionization takes place, but in weak acid partial ionization takes place. So more amount of ions are produced in the case of strong acids, less amount of ions are produced in weak acids. So strong acids example hydrochloric acid HCl, sulfuric acid H2SO4, HNO3 nitric acid. So these acids are mineral acids also, that is they are from mineral origin. Then weak acids example acetic acid. Acetic acid is CH3COOH that is present in vinegar. Then citric acid, tartaric acid, formic acid, oxalic acid. So these are all weak acids. They are organic acids also since they are of organic origin. Then another weak acid is carbonic acid which is present in soda water, that is H2CO3, which is actually a mineral acid but it is a weak acid. So this is about acids. Now let's see bases. In the case of bases, we will see the properties. It turns red litmus blue, it turns methyl orange yellow, it turns phenolphthalein pink. So you know litmus is a natural indicator, methyl orange and phenolphthalein they are synthetic indicators. So in aqueous solution, like acids, it also ionizes and produces OH minus ions or OH minus aqueous. They are called hydroxide ions. So hydroxide ions are formed in the case of bases. Then in aqueous solution it also conduct electricity. Then the chemical reactions with metals it produces salt and hydrogen, with acids it produces salt and water, with non-metal oxides it produces salt and water. So acids plus base, again neutralization reaction. Non-metal oxides are acidic in nature, so again there is a neutralization reaction. So salt and water are formed. So let's see the equations. First one is sodium hydroxide, which is a strong base. Zinc is a metal, so base plus metal gives a salt and hydrogen. So here also hydrogen gas is evolved. Here the salt formed is sodium zincate. So the name of this salt is very important, which is sodium zincate. Then another reaction is acid plus base. So the similar reaction we have seen in the case of acid also. Salt and water are formed. Again base plus acidic oxide or a non-metallic oxide. So non-metallic oxide example carbon dioxide is taken here. So carbon dioxide is a non-metallic oxide which is acidic in nature, so we can expect a neutralization reaction. So the corresponding salt formed is sodium carbonate, Na2CO3 and water. So these are the chemical reactions. Then in the case of bases, water soluble bases are called alkalis. So examples are sodium hydroxide, potassium hydroxide, ammonium hydroxide. So bases are again classified into two, strong and weak. Strong acids, strong bases are sodium hydroxide and potassium hydroxide. So you have to study these examples: NaOH sodium hydroxide, KOH potassium hydroxide. So they are strong bases. Then weak bases: ammonium hydroxide, magnesium hydroxide. So ammonium hydroxide is NH4OH, magnesium hydroxide is MgOH twice. So these are examples of weak bases. So this is about bases. Now let's see about salts. Salts are of different types: acidic salts, basic salts and a neutral salt. So in the case of acidic salts, the pH will be less than 7. In the case of basic salt, the pH will be more than 7. In the case of neutral salt, the pH is 7. So acidic salt, the example is ammonium chloride. Ammonium chloride is an example of an acidic salt. So ammonium chloride, we have to find out the parent base and parent acid. So from ammonium chloride we can write ammonium hydroxide is the base and hydrochloric acid is the corresponding acid. So now let's see the strength of acid and base. Here this is a weak base, this is a strong acid, so it will be an acidic salt. So in this case CH3COONA, sodium acetate, is an example of a basic salt. Here the corresponding base and corresponding acid. That is, here it is NaOH, that is a strong base, acetic acid, that is a weak acid. So since it is a strong base, the salt is basic in nature. Then about neutral salt, sodium chloride is an example. The corresponding base is NaOH and the corresponding acid is HCl, and NaOH is a strong base and HCl is also a strong acid. Both are strong in nature, so it will be a neutral salt, and the pH is equal to 7. So these are three types of salts. Then so we have to study about some chemicals from common salt. So common salt is NaCl. So we will study some chemicals, important chemicals from common salt. The first one is sodium hydroxide. Sodium hydroxide is NaOH. It is prepared by chlor-alkali process. The reaction is NaCl H2O that produces NaOH, Cl2 and H2. So this is the reaction. Then NaOH is used in soaps and paper making. Then another important chemical is bleaching powder. This is calcium oxychloride, CaOCl2. The reaction is, the preparation is CaOH2, that is slaked lime with chlorine produces bleaching powder, that is CaOCl2. Then it is used as an oxidizing agent and disinfectant. Then another important chemical is washing soda. This is Na2CO3.10H2O, which is called a sodium carbonate decahydrate. So it acts as a cleaning agent. It can be used to remove permanent hardness of water. Then another important chemical is baking soda, that is sodium bicarbonate NaHCO3, sodium hydrogen carbonate or sodium bicarbonate. The reaction for the preparation of sodium bicarbonate is NaCl, water, carbon dioxide, ammonia. So these are the reactants to be used for the preparation of baking soda. So it can be used as an antacid for making baking powder. It is used in daily food. Then soda acid fire extinguisher. It can be used in soda acid fire extinguisher. Then another important chemical is plaster of Paris. Plaster of Paris is calcium sulfate hemihydrate. It is CaSO4.12H2O. It is obtained by heating gypsum at 373 Kelvin. The temperature is important. Calcium sulfate dihydrate is gypsum, CaSO4.2H2O. So it is used for plastering fractured bonds and for making decorative items. So these are the uses. Then we have to see some examples of hydrated salts. That means it contains water of crystallization. So water of crystallization means some fixed amount of water molecules attached with each molecule of the salt. Here the examples are copper sulfate pentahydrate or CuSO4.5H2O. So 5H2O, that is the water of crystallization. 5 molecules of water is attached with CuSO4. This is an example of a hydrated salt. Another example is Na2CO3.10H2O, that already we have seen. It is washing soda. It is washing soda Na2CO3.10H2O. So sodium carbonate decahydrate is another example for hydrated salt. Then another example is CaSO4.2H2O, that is actually gypsum. We have already seen. It is used for the preparation of plaster of Paris. So calcium sulfate dihydrate, which is gypsum, which is again an example of a hydrated salt. So this is about salts. So you have to use these concept map for revise this chapter, acids, bases and salts. So thank you all for watching.